10th grade English class. All right. I hear you guys have a cool project you've been working on. Mrs. Steveneller was telling me that you've been studying World War II in both your history class and you've probably read some things in your English class. And now you're ready to kind of summarize a lot of the stuff that you've been reading or studying in a report. And so it's come to my attention that you need to place blame. You need to figure out who you believe was a major player in World War II as far as the cause, okay? And so I guess you're going to write this paper. And what I'm here to help you guys do is actually something that we're going to be looking at a little bit in geometry. So if you're in geometry this year, we'll see this later on. If you're not in geometry, you had it last year. You should have somewhat of an idea what we're going to be talking about. And if you're in algebra this year, then this is what we'll be doing next year, okay? And so, you know, there's lots of different players in World War II who was the cause. But in the circle graph, I'm going to say that Mrs. Steveneller actually ages really well. In fact, I'm going to tell you that she's 102 years old. Okay, you may laugh, but she ages really well. And so, you know, here's a little math question for you. How old would that have made her at the beginning of World War II? I'll let you guys figure that out. But yeah, she's actually 102 years old. Looks great for 102 years old. Anyways, I'm going to say, let's start real basic with this circle graph that you guys are going to make. And what my job right now is I want to make sure that you guys know how to find the angle for the percentage that you're going to assign the blame to. So we'll start real basic and we'll work our way out from there. But eventually, you know, when you guys go to make up this circle graph, I hope that if you say, you know, so-and-so, I'm going to place blame on them for the cause of World War II at 20%. That you can actually find the angle at the center of the circle graph, okay? And so, yeah, that's what we're going to be working on. So, first thing you obviously have to do, you have to take a compass, draw your circle, make sure you mark out the center. That's going to be key here. And then you have to figure out what percentage the blame that you're going to place in the different areas, all right? And so, you know, well, let's start real simple. Let's say that 100% of the blame goes on Mrs. Steveneller for the start of the World War II, okay? 100% of the blame. So my question for you guys would be this. If 100% of this circle graph right here represents the blame on Mrs. Steveneller, what degree is this going to be? Well, if I start here and go all the way around, I hope you're thinking that 360 degrees is what we'd be looking at, okay? Now, I'm going to tell you this. Everything that we do as far as the degrees are going to be based off that. In fact, the percentage of the degrees is going to be a portion of those degrees, okay? So let's do another simple one here. Let me get in there. Oh, did it not come up? Oh, I'm way too far. There we go. All right. So again, I have my circle graph. I'm placing my center point so I know where to start, okay? And if I was to say that, okay, 50% of the blame, that's going to be written out there, 50% of the blame is going to be on Mrs. Steveneller, okay? So what I hope is happening in your minds right now is, okay, 50% of 360, well, that's simple. 50% of 360 is only 180 degrees. It's half, right? 50% is half of the portion that's there. So for those of you that have taken geometry and those who are in geometry know that 180 degrees is a straight line. And so I can go ahead and do something like this, okay? And I can go ahead and say that this portion of my circle graph is the blame that I'm going to put towards Mrs. Steveneller. Now, from there, you can actually break up this bottom portion however you want to do that. So, if I was to go ahead and say the bottom portion, one part of it, okay, let's say 25% of my circle graph is to blame on somebody else, okay? Well, what is 25% of 360 degrees? Well, it's a quarter, And I think pictorially, like in this graph here, most of you would recognize that a fourth of the circle would be 90 degrees. Now I should probably show this. So if I go ahead and take my protractor here, okay, and I rotate it, I want to make sure that this point right here, okay, I want to make sure that point is on the center of my graph. So let's move that down right there, okay. Now from there, if I'm going to measure 90 degrees, let me make this a little bit smaller. There we go, okay. 90 degrees, I'm going to rotate this so that that line corresponds, okay. That blue line, that black line right there, that 90 degree mark right there corresponds along the blue line, excuse me. Now what I'm going to do down here is I'm going to make a little point. If I can make a point, there you go, okay. And then I'm going to go ahead and take my straight edge, and I'll just go ahead and do this right there. Make sure I've matched it up correctly. Draw on my line. Oh, make sure the line's there. Okay. And now I can say that 25% of the blame for World War II goes in that area. Okay. And so I hope that part, those are pretty simple. Most people, I think, without much knowledge of circle graphs would know how to separate those things. But let's say you want to be a little more technical. Let's say that you want to assign the blame to, say, let's say you think Mrs. Siebeneller, we're going to blame her for 27% of the cause of World War II, okay? And so as I go back to my circle graph, obviously I want to put my center point right there. But the question then becomes is, what the heck? Where does 27% come from? Like how do I figure out what percent of 360 is that going to be? Well, and I know a lot of you are already figuring this out, and that's great. But remember, 27%, when I get rid of the percentage, I'm going to move that decimal point, which is currently right here. I'm going to move it 2 places to the left. So this is going to be 0.27. Okay? If I was to go ahead and give you a, let's say, 6 1/4%, okay, something we're working on in my pre-algebra class right now, then I would probably convert this to 6.25%. And then I'd still move it 2 places to the left. So as a decimal, 0.0625. Okay? So right now we have 27%. Now, if I'm excuse me, if I'm taking 27% of 360, okay, we know that this is the decimal of, most of you know, is multiplication, and then 360. Okay? So, excuse me, what we're going to do is we're going to take that 0.27, multiply it by 360, and see what we get here. So 0.27 times 360, 97.2, and that'll be degrees. Okay, so this equals 97.2 degrees. All right. Now, I'm not going to be super picky on this, guys. 97 degrees is really all you have to put down. I want to be as accurate as possible, but understand that 0.2 really isn't feasible on something like this. Now, what I would then do is I would start with my straight edge, and I would put my starting line down, okay? So if I go ahead and, a lot of times graphs will start with a horizontal line one direction or another, okay? So that's my starting line right there. So I'm going to go ahead and take this, make sure that the crosshairs of my protractor are right on the center point right there. I'm going to rotate this until it matches up on the 0 line right there, okay? Now, it's really important that you guys read this correctly, okay? And I know that there are some students that are in geometry that still aren't the most confident in reading the protractor. So let me just review this real quickly. You have your inside track, which goes from 0 up to 180, and you have your outside track when it goes from 180 back to 0. Well, the inside track right here is what you want to follow. You always want to start on the 0. If I was to put the horizontal line on the other side, I would start on the outside track. We want to start at 0 and build our way up. And so as I look at this, 97, actually I said this wrong, didn't I? Not percent over here. 97 degrees, okay? 97 degrees. All right, so 0, 80, 90, 90, 95, 97. If I can make a little point there, it's kind of hard because of shadow on my board. Let's see here. Okay, right there, 97 degrees. All right, so from there, I'm going to go ahead and rotate this around. Right, oh, back to there. And then I go ahead and draw that in. And that 97 degrees is 27% of my graph. Now let's think about that for a quick second. Visually, 27% is a little bit more than 25%. And remember that 25% was a right angle, right? Okay. And so this looks correct. This looks like the 27 degrees that we're looking, or 27% that we were looking for. Okay. So let's go with something a little bit bigger. I'm going to continue to build my circle graph from there. Let's say I want to say, let's just make 62% goes towards the blame of somebody else. Okay. So again, it's 62% of 360 degrees. So if I convert this to my decimal again, 0.62 of means times 360, okay, and we can work that out in our calculator here. Let's see here, 0.62 times 360, 223.2 degrees. 223.2 degrees, okay? Now, let's see here. 89. Okay. Now, how am I going to calculate this out? Because I don't have 223.2 degrees within my protractor over here. Well, here's what we can do. If I go ahead and take, okay, if I go ahead and take 223 and subtract 180, okay, we end up with 3, 4, and 43 degrees, okay. So from there, what I'm going to do is I'm going to make a little dot over here at the 180. Okay, and then I'm going to continue to rotate this around another 43 degrees. So if I start at 0, I want to be up in here at 43 degrees when I get to that mark. So there's 20, 30, 40, 1, 2, right about right there. Okay, 43 degrees. Yeah, it looks more like 42 degrees. I'll do one more. 43 degrees. Okay. It's kind of hard with my board. It's not the most accurate there. So from there, I'm going to go ahead and make a mark out here at 180. Okay. And then I'm just going to go ahead and connect the center point to that point right there. And this right here would be 62%. Okay. So from there, let's see if this makes sense here. We have 89% of our total graph made up. And that means we've got about 11% left over. 11%, see if we've done this accurately enough, 11% of 360, well, 0.11 times 360, let's see if that works out correctly here. 0.11 times 360, 39.6, okay? So if we have degrees, 39.6 actually, round that correctly, 40 degrees, okay? So let's see here, was I accurate with my graph? If not, I will be making a new video here in a little bit. Let's see, 40 degrees. I was off by about 2 degrees there. I must, yeah, the precision of, well, let me go back here. No, come on. Right there? Yeah, I mean, like I said, the board's not the most accurate, but if you can be within a degree or two of your construction of your circle graph, I think that's pretty good. So again, I hope that you understood how to figure out and how to set up the circle graph there. If you have any questions, obviously you can swing down and see me and I'll try to help you out. So good luck making your circle graph and placing blame in the correct place, and I'll look forward to hearing how things go. Good night.